Today I'm building a GPS RTK all-terrain robot. The chassis was 3D printed and printing all the parts for this project took a lot of time.
That's all of the links for the trucks.
And then there was assembly, which was actually quite enjoyable, and then fixing some mistakes with a Dremel because not everything was done perfectly. The robot is controlled with Raspberry Pi Zero and some custom electronics, and I'm using very fancy motors in this project. I will also show you around my workshop where I did some upgrades. Will it work in the end? Let's see. In case you are wondering why am I even building this project, well, of course, for the indie mower project. I started building my own robotic lawnmower and everyone was asking to use GPS RTK in this project, so I'm experimenting with this robot in order to implement properly GPS RTK on the indie mower in the future. And this is only part one of hopefully two-part series. If something is not gonna work as I wanted it to, it might be a three-part series, but this is part one where I focus on building the chassis, and in part two I will focus on GPS RTK and making the robot drive between the waypoints. So subscribe, don't miss that. Step number one is always to design a project, but not this time, because this time I'm trying the idea of outsourcing. I found someone on Fiverr that could design a project for me. I provided this sketch, the design of the motor that I'm using and rough dimensions, and in the end I got that. And I have to say I'm pretty happy with this design. There is a lot of things I like about it, but after thinking about the design and especially my drawing after a few weeks, I realized that there is a lot of things I can do better. So I started redesigning the project a little bit here and there, and in the end I got that. The design of the trucks and wheels is basically the same. The front and the rear bumper are very similar, but I changed the idea of using steel profiles for the construction, and now I'm using threaded rods. And I think that was a much better choice. There is also plenty of space for batteries, electronics, future upgrades, and the design is quite modular, so I can simply replace whatever I need without reprinting the whole project once again. And if you are wondering what software did I use to design such a project, I used Fusion from Autodesk, my favorite CAD software. So just like that, design is done. Now it's printing time. Printing took several days, and that's the only clip I have, so I hope it works, and now we move to test assembly. I was more than sure that if there's something that won't work in this project, it's probably going to be the tracks and the wheels. So that was the very first thing that I wanted to test. I grabbed a piece of wood, a few screws and bearings. I'm learning to pronounce this word and I hope right now I do it right. And with those elements I assembled a very simple test rig to check if the tracks work properly on the wheels. That is so cool. It's not perfectly tightened, but it's tightened enough to not fall. It is running very smoothly, but I modified the design and now we also need plywood parts. Let's make those. Now I will make the side plates that will connect both wheels together and the truck will be running on that. And for that I will use plywood, and I made this little technical drawing with all the dimensions. Now I just need to copy the dimensions on this piece of plywood. It's quite old. If you're wondering about this technical drawing, I did that in Fusion 360. It's very simple to do it and I can actually show you. With your design open, just go to Design, Drawing from Design. On the right, choose Select in the content and then choose the part that you want to make a drawing of. You can also modify the dimensions and press OK. We need to change the orientation of the part, in my case to right. As you can see, the part is a bit too small, so we can also modify the scale. Once you are happy with that, just click on the drawing to place your part. With the dimensions tool, we can start adding dimensions to the drawing manually, but we can also get rid of all of them and choose auto dimension. This will automatically generate all the dimensions, and in general this is a good starting point to modify it manually. And then just export to PDF, print and go back to the workshop. Never underestimate the power of simple hand tools. And then I had to do it all again to make the second plate, but we'll skip right to the assembly. Just look at this logo. That looks so cool. It took like 18 hours to print both of this, but it was definitely worth it, and now I just need to clean it a little bit. These panel holding pieces are only visible from the inside, so I just printed them with the leftover filaments to get rid of a few extra spools I had. The threaded rod I'm using is metric 10mm, and I have this special hole in the design so that the nut can hide inside it. To connect all these links, I'm simply using filament. And I cut it, and then I can put it in the hole, and later I will just cut the additional amount of filament and press it with a hot screwdriver that I will heat up with like a candle or something. I've tested this setup before and it works quite well. Trust me, that stuff is very strong. It's strong, so it should last. You know what else lasts? New skills gained with the sponsor of this video, Skillshare. Skillshare is the largest online learning community with thousands of classes led by industry experts on pretty much any topic you want. From the creative stuff like drawing and design to electronics and programming. Let's say that you want to start building projects that I'm showing in this video. There is a great class on Python, a very universal programming language. It will teach you all the basics so that you can start building your first apps, websites, robots and AI related programs. But if you are more into electronics and embedded programming, there is a great class by Mark Fraunfelder on Arduino. It will teach you how to write your first programs, how to connect sensors and what are the most important functions. And if programming or electronics is not for you, you can find there a lot of classes on all the creative topics like filmmaking, drawing or design. Recently, Skillshare also introduced Learning Paths, which is a curated sequential collection of classes that will let you master a specific topic. For example, filmmaking. I'm trying to improve my video editing a bit in the last few videos, and I hope you noticed. There is a great learning path on that made by some very big YouTubers. And the best part is, the first 500 people that will click the link in the description will get 1 month free trial of Skillshare Premium. So go check out Skillshare. Remember that supporting the sponsor of this video means also supporting this channel. Thank you very much, and now we go back to the robot. It's definitely one of these projects that when you assemble it, you are just like, let's appreciate this beauty for a second. The problem is now I have to completely disassemble the robot because I forgot that I have to figure out how to use the motors that I'm using with Arduino, which turned out not to be as simple as I thought it will. Motors for this project were provided by a company called Lidshan that is manufacturing industrial servo motors. The model that I'm using is powered with 24 volts, there are other versions available and my version used CAN open as the communication, but there is also RS232 if you prefer that. Huge plus of these motors is that the driver is already integrated and the form factor is quite small, and that makes it perfect to use in any kind of project. Okay, so here's what was happening for the last 3 days. I disassembled the robot to take out the motor because I had to figure out how to control it with Arduino, and that became a huge problem because it uses CAN open, which I thought is like, you know, the same thing as CAN bus, which I already use, for example, in this robot. Turned out it's a bit different and a lot more complicated, and I wasn't able to just simply send a message and control the motor, and I have been trying for the last 3 days to read documentation, find examples online and libraries. Nothing worked. ChatGPT, Gemini, any other LLM was not able to help me, and then I tried Grok from Twitter or X, and it worked. Look at that, it turns into the motor mode and it rotates. Let's do that again. It's really not a great feeling when you are stuck for 3 days trying to just simply connect to the motor, but once it works, I feel so motivated to work on the project. Let's do that. In the end, the code that I used to control the servo motor over CanOpen looks like this, and it's obviously Arduino code. I also made a custom PCB a while ago on a CNC machine, and this PCB connects Arduino Nano with the MCP2515 module, which is the CAN module. The PCB was designed in KiCad and then converted to G-code with FlatCam. I soldered all of the components and added a little label so that it's easier to use in the next projects, and that was definitely worth it because this PCB was made like 3 years ago and I've used it already in 5 or 6 projects. And in this project, of course, I used the RP design rules and the holes pattern, so instead of designing the holder for the Raspberry Pi Zero, I can just download it from the website for free, put it in the slicer, and then start printing without designing it on my own. The robot will be controlled by Raspberry Pi Zero, and the DIY PCB that I just showed you is only an interface between the Raspberry Pi and the motors. So that's the space for the electronics. The ORP holes are there so that everything is easy to attach, and as you can see, it truly is, both for the Raspberry Pi and this PCB. I can hide the cables here in the front because there is plenty of space. Here in the back I have the motors, and I also have to put in here the batteries and the power bank to power the Raspberry Pi. Everything is connected and the app is already running on the Raspberry Pi. And take a look at that. With a joystick, I can just so easily control the robot. This is so cool. And I connected the GPS RTK module to the Raspberry Pi, and with that I can see the map on my phone, which I have to blur because I don't want to show you my location, but it works, and the motors are so silent. And this is a very simple web app that I made, and it is running on the Raspberry Pi, and I'm connected to the Raspberry Pi with my phone, so there is no like any app running on my phone that I had to install. It's simply a website with a joystick that lets you control the robot. Isn't that cool? I know there will be questions about this app that I made, so it's a simple website with a joystick at the top, a map at the bottom that shows the current RTK location, and a few buttons at the bottom that let me add waypoints, clear them, and turn autonomous mode on. It's a simple Flask app with just a few files, and I will tell you more about it and hopefully extend it in the next video. If you like the chassis that I made for this project and you would like to print and build it on your own, you can buy the digital files from my store, that is industry.cc/store. The design includes STL, 3MF, STEP, and Fusion file, all in the assembly version as well as ready for printing. The link will be in the description. Small update on my GPS RTK base station. I 3D printed a new smaller box. It is connected now to power here, and I bought the extension cable for the GPS antenna so that it can reach the top of the roof. And at the end we have this nice flap. How do I secure a filament in place on the tracks? I just use a screwdriver, a blowtorch. I hit up the screwdriver like this, and then I can just press on the end of filament, and that way it melts and is secured in place. I am aware that this process can be improved with, for example, a soldering iron, but I don't want to get it messy and I don't really care about this screwdriver, so it works for me. Every single time when I build a project where it needs to be outside, it's super cold. It was when I was building the weather station that is somewhere there 2 weeks ago, and it was like super sunny after that, and now again it is cold and I have to build the robot and test it outside, but let's do it.
I think I know what is the problem. Take a look at that and that track. This one is a lot more tensioned, this one is not. And that's all because of the front wheel that is not tightened all the way and it is moving a little bit. And because of that, this track is locking the motor. That is causing both motors to stop immediately because the torque is too high, and that's probably just a safety feature, so I will tighten that.
So now obviously I need tools that I have in my workshop right here that I built with my dad. And
okay, so just recently I installed the lamps and that made this workspace a lot nicer to work in, but second thing is obviously the organization of all the tools. If I need a key, like the number 17, it's right here and I can just go back to work and fixing the robot. Now there is a new problem. This wheel collides with the screw at the bottom. That is just a few millimeters too close to the wheel. I'll just add the washer between the plate and the wheel and that should help.
no collision, and it feels pretty solid. Perfect.
Need to close the track again.
Okay, so throughout the experiments I already done, there is one conclusion from all of that: the motors lack torque. They are super powerful. Single motor is 200 watts, so 400 watts for such a robot, that's a lot of power. But yeah, they do not have a gearbox, and for that reason they cannot handle all the torque that is required to go uphill or sometimes even turn. We'll connect to the robot and let's see if it drives now properly.
Time for plan B.
And my plan B is this: wiper motors. Literally the same units that are used in a car, and you can buy them pretty inexpensive if you want to buy used ones. I bought them new because I wanted to have it perfectly brand new with a lot of torque to make sure that it will work, and that's how it looks like. But it's a pretty small motor, pretty inexpensive motor, and it delivers plenty of torque, which I need for this project, so hopefully that will solve the problem.
If you are curious how to wire these motors, it turns out that there are two cables, but one pin of this connector is also connected to the case, and that is actually the ground, so I can just connect it here or here, whatever. It has to touch the ground, and the two cables are speeds. So if I connect it here and then let's say to the blue one, this is the high speed mode, and then I can change it to the green one, which is the low speed mode.
Completely disassembling the robot. Here we go again.
I have a plan. I'm not proud of it, but it will totally work. So the motor will be attached here. I'm simply not able to go with this motor through the case, as you can see. And that's why it's gonna be like this, and I have to cut the hole right here under the motor so that it fits in the case.
And it was exactly at this moment I realized I made a mistake. Modification and adding new motors was going so well. And then I realized that it's not simply gonna work. Because of the hole right here, the motor is going to stick out of the case. And that will, well, obviously collide with the track. I'm a little bit angry, but also Let's treat it as an opportunity to learn and become a better maker, designer, roboticist. And here we are. It ended as it started, everything is in pieces and I do not have a functioning robot, which is not good, but in order to move forward I have to decide whether I stick to fancy servo motors or I use the wiper motors. Honestly, I have no idea what's the better choice at this point and I would love to hear your thoughts in the comments. Servos or wiper motors. For these servos, I'm planning to design a gearbox. I already started doing that and I think that could totally work. For the wiper motors, I would have to make the robot a bit thicker, which also means reprinting all the parts and making new plates on the sides. And probably even making the wheels a bit bigger. Which way should I go, or should I build two robots? Let me know in the comments. As I mentioned, this is only part 1 of working on this project, and hopefully in the second part, and the last one, we will finally have the robot working and going between different waypoints based on GPS RTK data. I hope you enjoyed this video. Don't forget to check out the link to Skillshare, which is in the description, and subscribe to my channel to don't miss my future projects. See you in the next video, bye!